Okay, so share £240 in the ratio 5 to 7. So if we're splitting this in a ratio, let's have a look. We've got in total here 5 plus 7 equals 12 parts. Okay, so if we split this into 12 parts, we could do 240 and divided by 12. And 240 divided by 12 is 20. So in each part there's £20. Now there was 5 parts and 7 parts, so those 5 parts are going to be 5 lots of 20, which would be £100, and the other part there was 7 parts, and that times 20 would give us £140. So splitting it in the ratio 5 to 7 gives us 100 to 140. And the last little check you can do here is just to add these two together, just to make sure you do get that £240 that you started with. So we're happy with that as a final answer. So Craig and Ian share some money in the ratio 8 to 3. Craig receives £32. How much does Ian receive? Well, C to I, Craig to Ian, was in the ratio 8 to 3. And it said that Craig receives £32. So that is this first number 8 here, that is 32. So what we've got to think about is how do we get from 8 to 32? So 32 divided by 8, which we can do to the side, 32 divided by 8 is 4. So we must have times by 4 to get there. So if we do the same to the other side, times by 4, 3 times 4 is 12. So there we go. How much does Ian receive? Ian receives this 12. So I'll just say £12. Final answer. So Emily and James share some money in the ratio 4 to 7. James receives £21 more than Emily. How much do they share between them? So Emily to James is in the ratio 4 to 7. Now it says that James receives £21 more, and if we look at these two numbers here, from 4 to 7 is an extra 3 parts. There you go, it's an extra 3. So that extra £21 is 3 parts. So if 3 parts of this ratio equals £21, then 1 part must be, to divide that by 3, must be £7. And from there we can work out how much they both receive. If it was 4 to 7, let's get rid of this little bit down here. And each part is now worth £7. Well, 4 times 7 gives us £28 for Emily, and 7 times 7 gives us £49 for James. So Emily receives 28 and James receives 49. It says how much do they share between them? So if we can add these together, it gives us the total amount. So 49 plus 28 gives us 7 and 7, so £77. There we go, so they share £77 between them. A to B is in the ratio 3 to 5 and B to C is in the ratio 2 to 1. Work out the ratio A to B to C. So if we write out A to B to C and start to write what we've got so far, now it says A to B is in the ratio 3 to 5 and then it gives us B to C. So there's an overlap in these, there's a B in both. So I can't put another number just over the top of the 5, so I'm going to start a new level. I'm going to write the other one underneath. So B to C is 2 to 1. Now looking at this, if I can make these middle numbers the same, I can merge these ratios together, I can squish them together essentially. So let's think, 2 and 5 can make 10. So if we times the top one by 2, that would make that 5 a 10, and we'd have to times the bottom one by 5. So if we times the top one by 2, that 3 becomes a 6, and the 5 becomes a 10. Looking at the one below, timesing that by 5, 2 times 5 makes 10, which we've already got in the middle, and 1 times 5 is 5, and there's my ratio A to B to C, 6 to 10 to 5. Just have a look to see if you can simplify in any of these questions, but it doesn't actually ask us to simplify it there. So a mobile phone costs £480 in the UK and the same phone costs $600 in America. The exchange rate is £1 to $1.29. Where offers the cheapest price? So we have two options here. We could put them both into pounds or we could put them both into dollars. I'm going to decide to put them both into pounds. So as we can see, we've already got the cost in the UK is £480, but we're going to have to convert this $600. So looking at our exchange rate, the actual number itself, we get a bigger number in dollars. So we know that our answer here is going to have to get smaller. So we only have one decision to make, and that is either we times or we divide by this 1.29. Okay, so it's times or divide. Okay, but we know logically we're going to get a smaller number in pounds. So let's go for this. When we do convert back, we are going to divide. So it's going to be 600 divided by 1.29. And we'll do that on the calculator. 600 divided by 1.29 gives us, not a very nice number here, £465 and 12p to the nearest penny. Now it doesn't matter about all the decimals after that, because at the end of the day we're looking at which offers the cheapest value, and as you can see there, £465.12 is cheaper than £480. Obviously there is another way of doing this. We could convert them both into dollars. So instead of doing that, what I could do is times this number here by 1.29, and 480 times 1.29, if again we work that out on the calculator, gives us an answer of, in dollars, $619.20. And again, that's more than $600, so again we would state that it's cheaper in America. The ingredients to make 16 biscuits are 150 flour, 100 butter, 75 sugar and 12 grams of almonds. Alice has 140 grams of butter and is going to make enough biscuits for 24 people. Does she have enough? Well, whenever we're doing this, look, this is a recipe for 16 and we can start to break this down, particularly a non-calculator way here. If we want to get half of that, that's going to be 8. So half of all of those would be 75 grams of flour, be 50 grams of butter. It'd be not a very nice number here. 75 divided by 2 is 37.5 grams of sugar, and half of 12 is 6 grams of almonds. Now we could keep going. We could halve this again for a recipe for 4. We could halve it again for a recipe for 2. We could halve it again for a recipe for 1. Or we could have just divided all of these by 16 if we had a calculator to straight away get a recipe for 1. I'm going to assume this is a non-calculator though, but it says we want a recipe for 24 people. And if we have a look, 16 people, oh, didn't mean to erase that, there we go. So 16 people in this recipe and 8 people in this recipe. Well, in total, 16 plus 8 is 24 people. So if we combine these together, the recipe for 16, the recipe for 8, that'll give us a recipe for 24. So for 24 people, we can add these together. So 150 plus 75 is 225 grams of flour. 100 plus 50 is 150 grams of butter. 75 plus 37.5, not very nice one there, gives us 112.5. And 12 plus 6 gives us 18 grams for that last one. Now it says, we're actually only looking at the butter here, but I've gone ahead and done the whole recipe. But it says Alice has 140 grams of butter, and if we have a look, the actual amount of butter that we have, or we're going to need, is 150 grams. So if she only has 140 grams, we can say no. Okay, she needs 150. But there's a little process there for working out any sort of recipe there that we can make combinations of those smaller amounts of recipes. In a store, you can buy 2 kilograms of washing powder for £3.40 or 5 kilograms of washing powder for £7.20. Which size is best value for money? There's 2 ways of doing this. I always like to split the page up. So we've got 2 kilograms or we've got the 5 kilograms. Okay, and the 2 kilograms is £3.40 and the 5 kilograms is £7.20. Now we can either build this up to the same amount of kilograms for each, so we could think actually, well, what if we bought 10 kilograms of each? Well, that would be 5 of these would be 10 kilograms, so if we times £3.40 by 5, we get £17. Or we can have 2 of these, and that would be £14.40. And it's quite clear to see there that if we buy 10 kilograms of each, the 5 kilogram one is our cheaper option there. So we just make that statement, the 5 kilograms is cheaper. There's another way of doing this as well. So if we think along the lines of something easy, let's imagine 2 apples cost £1. So 2 apples equals £1. Well, to work out the cost of 1 apple, we would do the amount of apples divided by the cost. Sorry, the cost there divided by 2. So we would do £1, the cost, and we divide it by 2 apples. That will give us 50p per apple. And we can apply this same logic up here. So we can do the cost of each divided by the amount. So for the first one, looking at the 2 kilograms and £3.40, so we can do £3.40 divided by 2, and that gives us £1.70 per kilogram. Okay, per kilogram. We can also have a look at the next one in the same way, so £7.20. And we can do £7.20 divided by 5, and that gives us, let's have a look, £1.44. So £1.44 per kilogram. And again, you can see which one's cheaper there per kilogram. It's the £1.44, again, the 5 kilogram box. So 2 different ways, one non-calculator, one with a calculator to work out a better value. 3 tins of beans and 4 jars of jam weigh 2,080 grams, and the total weight of 5 tins of beans is 1,800. Work out the weight of 1 tin of beans and 1 jar of jam. Well, straight away we can work out the weight of 1 tin of beans from this, because it says 5 tins of beans is 1,800. So if we do 1,800 and divide it by 5, we get the answer 360. There we go. We might have to do a bit of bus stop for that, but we can do that. 5's into 1,800. 5 into 18 goes 3, remainder 3. 5's into 30 goes 6, and then 0. So 360 grams, and that is for the tin of beans. So tin of beans. There we go. It then says 3 tins of beans and 4 jars of jam weigh 2,080 back in the first line. So if we work out the weight of 3 tins of beans now, well, 3 of those would be 360, 360 and 360. If we add those all up, we get 9, 10, 1,080. So that's the weight of those tins of beans. So if we subtract that away from this original amount, so 2,080 take away 1,080, that leaves us with 1,000 grams. So those 4 jars of jam, so 4 jars equals 1,000 grams. And we want to know the cost of 1, so we can divide that by 4, and it gives us 1 jar equaling 250 grams. So there we go. 1 jar is 250, and 1 tin of beans was 360. Right, so 180 grams of copper is mixed with 105 grams of zinc to make an alloy. The density of copper is 9 grams per centimetre cubed, and the density of zinc is 7 grams per centimetre cubed. Work out the density of the alloy, which is just a mixture of metals. Now, whenever we've got this sort of mixture going on with mass, density and volume, I like to tidy it up in a two-way table. First things first, we definitely need to make sure we write down our formula. So density equals mass over volume. Okay, and you can stick that into a formula triangle if you want, which I am going to do. So density, mass, volume. There we go. So drawing ourselves a little two-way table to tidy this up. Let's have a look. Now for each thing we're going to need a density, we're going to need a mass, and we're going to need a volume. We have the copper, we have the zinc, and we have the alloy. I'm going to split this all up into a table. Right, so let's fill in what we've got. We've got a mass of the copper of 180. We've got a mass of the zinc of 105. It also gives us a density of the copper, which is 9, and a density of the zinc, which is 7. And it wants us to work out the density of the alloy just here. Now we can't add these densities together because the density is going to change as they're mixed together. So if one's 9 and one's 7, the density is going to be somewhere in between that. But what we can work out is the volume of the copper and the volume of the zinc. So looking at your formula, to get volume, we would do mass divided by density. So mass divided by density. So I'm going to do 180 divided by 9 for this one, which gives us a volume of 20. And for the zinc, I'm going to do 105 divided by 7. And 105 divided by 7 is 15. Now masses and volumes can be added together, so we can add these together. We've got 20 and 15, so 35 centimetre cubed is going to be the total volume of this alloy. And we can add masses together, so adding these two together as well. We can do 180 plus 105, which is 285 grams. And then we can finish this question off. It wants the density. Remembering density over here is mass over volume, so 285 divided by the volume, which is 35, and 285 divided by 35 gives us not a very nice number here, but we get 8.142857. It's actually a little recurring number there as well. Now this question would normally ask you to write that to 1 or 2 decimal places, so we would just round it however the question actually asks. But if it doesn't ask us, we write down the full number there, which is 8.14257 with those little recurring dots. So a car has to travel 30 miles along a motorway in 24 minutes. Will the car have to travel faster than 70 miles an hour to get there in 24 minutes? Now I'm going to do this as a non-calculator one, then we'll have a look at one that's maybe a little bit more calculator based. But if it has to travel at 70 miles an hour or more, now 70 miles an hour means that we go 70 miles in 60 minutes. So 70 miles equals 60 minutes. Now what we can do is we can actually start to break this down. So if I have a look, what can I divide both sides by? So if I can divide both sides by 10, that would mean I would go 7 miles in 6 minutes. Okay, dividing that by 10 as well. So you can have a look to see if you can ever break these down this way. So 60 divided by 10 gives us 6 minutes. There we go. Now it says we've got to go 30 miles and we've got to go there in 24 minutes. Now just having a look at this speed here, 7 miles equals 6 minutes. So travelling at this speed, if I wanted to get to 24 minutes, have a look, 24 minutes, we would times that by 4. So if I do the same to the other side and times that by 4, that gives us 28 miles. So travelling at 70 miles an hour, in 24 minutes we would go 28 miles, and the question said a car has to travel 30 miles, so it's not actually going to be able to make that 30 miles in 24 minutes. It's only going to be able to go 28 miles. It would have to go over 70 miles an hour, so I would make obviously that statement no. Okay, it's only going to go 28 miles, or it's not going to be able to do it in that sort of speed. David travels from Birmingham to Glasgow. He drives at an average speed of 70 miles an hour for the first 3 hours, and he then drives an extra or a further 150 miles at an average speed of 30. Work out his average speed from Birmingham to Glasgow, so for the whole journey. I'm going to take a similar approach as I did to the density question here, but I'm going to think about obviously using my formula now. So I want to write down my formula, which is speed equals distance over time. And again, we can put that into a formula triangle if we want. And I'm going to do that. So speed equals distance over time. So speed, distance, time. I'm going to use a little formula triangle. So let's see if we can tidy up what we've got here in a little two-way table. And again, for each one, we're going to need a speed, we're going to need a distance, and we're going to need a time. Now we've got the first part of the journey, the second part of the journey, and we've got the total journey. So let's split this all up and write in what we've got so far. Okay, so at the moment we have, he drives at an average speed of 70 miles an hour for the first 3 hours. So this first one here is 3 hours and he drives at a speed of 70 miles an hour. The second part, it says he drives 150 miles, which is a distance, and he drives at an average speed of 30 miles an hour, so that's going to go just above there. And we want to work out essentially the average speed for the whole journey, which is this one just here. Now again, we can't join together speeds, it's going to be somewhere there in between the 70 and the 30. So let's have a look at what we can do. So this first distance here, let's see if we can work that out. So looking at our formula triangle, distance is speed times time. So we can do speed times time to work out that distance. So 70 times 3, the speed of 70 times 3, says it will go 210 miles. So again, we can add these together to get a total distance at the end there, because that would be 360 miles in total that he's got to do. So all we've got to do is get this total speed here, this total time, and then we'll be able to work out his speed. So looking at this bottom one here, which is the time for the second one. So to get time, you do distance divided by speed. So distance divided by speed will be 150 divided by the speed of 30, which gives us a time there of 5. So that means in total he's going to be driving for 8 hours. Now we can work out his total speed, because we've got his total distance and his total time, and speed is distance over time. So it's 360 divided by the total time of 8 there, and 360 divided by 8 gives us an answer of 45 miles per hour. So I'll just write that down, 45 miles per hour. Again, keeping it all nice and tidy in a table so it all makes sense. We've got some proportion here. 6 taps take 3 hours to fill a tank with water. How long will it take 9 taps to fill the same tank? And then we're going to state any assumptions that we've made. So if 6 taps take 3 hours, it will take 6 times as long as that for 1 tap. So 1 tap would take 3 times 6, which would be 18 hours. It takes 6 times longer. So 1 tap takes 18 hours. So from here, if we know how many taps we've got, we can just divide this 18 hours by however many taps. If we have 2 taps, we can divide it by 2, which would give us 9 hours. We could do 3 taps, divide it by 3 would give us 6 hours. But this particular question here said that there's 9 taps. How long would it take 9 taps? So if we do 18 hours divided by the 9 taps, it gives us a total answer of 2 hours. So these questions are all about working out first, how long would it take 1 tap, or whatever this question's actually about normally. So it says state any assumptions that you've made. Well, I've assumed here that all these taps are running at the same rate. Okay, that's my assumption. All taps run at the same rate. There we go. So obviously in that original statement there, 6 taps take 3 hours, while one of those taps might be running a lot faster than the other, and that would change our answer. So we are assuming that all the taps are running at the same rate. Okay, and looking at some ratio and proportion now. So this says James has a bag full of counters. He takes at random a sample of 20 counters, marks them all and puts them back into the bag, and then he takes 30 counters at random, and out of the 35 of them are marked. Estimate how many counters are in the bag. So we're looking at capture, recapture here. Now if we just make a few statements, because we're going to assume that the sample is proportional to the next one that he took as well, or to the rest of the counters in the bag. So initially, he takes a sample of 20 counters out of we don't know. That's what we're trying to work out, so let's call that 20 over x. On the next time, he takes a sample of 30 and 5 of them are marked. So we'll say that that's now 5 out of 30. So out of the 35 were marked, but previously it was 20 that were marked out of something we don't know. But we are going to assume that these are proportional. So in order to work out how many that x value is, we just have to think, okay, well, how do we get from 5 to 20? And we do that if these fractions are equivalent by multiplying by 4. So in order to get that number on the bottom there, we would multiply this by 4, and that would give us 120. So our answer would be 120 counters. Okay, obviously we are making some assumptions here. We are assuming that no additional counters were added to the bag in between the two samples, and also none were taken out as well. And obviously there's little silly things like we're assuming that the marks haven't actually come off the counters or anything like that in this time frame. Okay, so that is capture, recapture there. Okay, on to some direct and inverse proportion. So there's two formulas that we can use here. It says A is inversely proportional to B. So it's either going to be A equals K lots of B, or A equals KB, or it's going to be A equals K over B. So these are the two that you have to remember. Now with inverse proportion, it's this one here, where K is being divided by B. So we're going to use that formula, so just make sure you write them down straight away. And then it gives us some values to put in. So it says 15 for A, so 15 equals K over, and it says B is 4. So we can solve this for K. We can times both sides by 4 to isolate K there, and we get 60 equals K, or K equals 60. And now what we can do is we can put that 60 back into the original formula here, and that will give us our formula. So A equals 60 over B. And that is a formula for A in terms of B, and sometimes you might just be asked just to write a formula for A in terms of B, and there it is. But this question says find the value of A when B equals 12. So all I've got to do is stick B equals 12 into my formula down here. So if we do that, I'm going to do it to the side, we get A equals 60 over 12, and 60 divided by 12 equals 5. So our final answer there is 5. So every time you just think which formula am I going to use, plug your pieces in, find your value of K, and then reuse that in your formula for whatever values you need. Okay, so this question says directly proportional to. So we're going to be using the other formula this time. It's A equals KB. But you've got to read the question carefully, because this one says directly proportional to the square root of B. So I need to put a square root in with my B. So using the same formula, but just putting my square root in. Remember, it could say squared or cube rooted or anything. But that's my formula I'm going to use. Then it says when A is 18, B equals 16. So if we put those values in, A is 18, so 18 equals K, and I'm going to put a times sign in here, the square root of 16, and you can do that in your head hopefully. The square root of 16 is 4. So I'm just going to put K times 4. Now again, we can actually find the value of K here. We can divide both sides by 4. So if I divide both sides by 4, we get a decimal here because it's 18 over 4. So 18 over 4 equals K. Now if we simplify that down, let's have a look. Divide top and bottom by 2, we get 9 over 2. Which we can either leave as that or we can turn into 4.5. I might just leave it as 9 over 2 for the moment, see where we end up with this, but we've got our value of K. So if we put that back into our formula now, so just putting that back up here for our value of K, we get A equals 9 over 2 root B. There we go, and there is our formula for A in terms of B. A is 9 over 2 or 4.5 times root B. And then it says find the value of B when A equals 2. So if we put those into our formula there, A equals 2, so 2 equals 9 over 2 root B. There we go. Right, so we need to rearrange this. So I need to divide both sides by 9 over 2 or divide both sides by 4.5. If we've got a calculator, that's fine. If we don't know, we can just do 2 divided by 9 over 2. Remember in fraction rules, that would be 2 over 1, and you would times it by the flipped version, 2 over 9, and that would give us 4 over 9. So 4 over 9 equals root b. And if you've got a calculator, you can just type that straight in. So 4 over 9 equals root b. In order to find out what b is, we just need to square both sides. And when you square both sides there, 4 squared is 16, 9 squared is 81. There we go, and we get 16 over 81. So our final answer there is a fraction. There we go, just following those normal fraction rules there. That would have been absolutely fine with a calculator, but just a different way to approach this if it is non-calculator. Okay, so we've got one of these questions with lots of ratios going on. It says in a bag of shapes are either circles or squares, and then they're white or black, and gives us some ratios about them. And it wants us to work out what fraction of all the shapes are white. Now if I start to break this information down a bit, it says fraction, so I'm going to just start to turn these into fractions. Now it says we've got circles and squares, and that's in the ratio 3 to 5. So in total that's 8, so we've got 3/8 that are circles, and 5/8 that are squares. And then it gives us some information. So it says the ratio of black circles to white circles is 5 to 7. So if we have a look at this, we've got black and white, and that is 5 out of 12, 5 plus 7, and 7 out of 12 for the white ones, okay? And then it goes on to the squares. So we've got 1 to 3, and again that's black to white. 1 to 3, so it's 1/4 and 3/4. Now if I treat this just like a probability tree, because it asks me for the total fraction, so if I think, well, what's the probability of picking a white, a white shape? So if we have a look at the circles, we can go through the 3/8 and down the white shapes there to 7/12. So just like on a probability tree, we would do 3/8 and multiply it by 7/12, and that's going to tell me the fraction of circles that are white. I can do the same with the squares, so 5/8 multiplied by that one there, 3/4. So 5/8 multiplied by 3/4, and that's going to tell me the fraction of squares that are white. Now if we work these out, times in fractions is nice and easy. So times in the top, let's just move this to the side a little bit. So times in the top there, we would get 21 over 96. Times in these on the right, we would get 15 over 8 times 4, which is 32. And there's our two fractions. Now just like with probability here, we just need to add these two together, which means we need a common denominator. So not very nice, but you might have spotted here that this fraction simplifies. And if we divide the top and bottom by 3, 21 divided by 3 is 7, and 96 divided by 3 is 32. So actually we can now add these two fractions together. We've got 7 over 32 here and 15 over 32 here. And if we just add those together to finish that off, now that there's a common denominator, 7 over 32 add 15 over 32 gives us a final answer of 22 over 32. And again, you could even simplify your answer there if you want. It doesn't say to, but if we halve both of them, because they both divide by 2, we get 11 over 16. So completely up to you there. We've got two different answers, 22 over 32 or 11 over 16 would be a fine answer there. But obviously in that scenario it's quite nice because one simplified to make a common denominator. If not, you just have to apply your normal fraction rules there to get your common denominator. On to some equivalent ratios here. So when ratios are equivalent, if we think about this logical idea here, 1 to 2 is also equivalent to 2 over 4. Now we can apply a little trick here, because if that is true there, we can also make the statement that 1 over 2, the left over the right, is equal to 2 over 4. And we know that that's correct, isn't it? 1/2 is equal to 2/4. And I'm going to apply that same trick to this question here. Even though we're involving some algebra now, we've got 3x plus 5, that's not a 3, we've got 3x plus 5 in the first one. So 3x plus 5 over the second one there, x plus 4, is equal to the first one, 2x plus 4 over x plus 2. And there we go, now we've actually got an equation that we can solve. So this is more of an algebra question, but it's a trick with the algebra there, with the ratio. So what we can do, and we've got two fractions either side, we can cross multiply. So I'm going to times the x plus 4 up to this side and times the x plus 2 up to the top of this one. So we get a double bracket, we get 3x plus 5 multiplied by that right denominator, x plus 2, and that is equal to 2x plus 4, what's on the top of there, multiplied by that left denominator, which is x plus 4. So all we need to do now is expand both these brackets out. I'm going to do this in quite a quick step. So the first one, we get 3x squared plus 11x plus 10. And on the right one here, we get 2x squared plus 12x plus 16. So we've got quadratics here and we just need to make it equal 0. I'm going to do this in quite a quick step. I'm going to move everything here on the left hand side to the other side. So I'm going to minus 2x squared, minus 12x and minus 16, and that's now going to equal 0. So 3x squared minus 2x squared leaves us with x squared. 11x take away 12x leaves us with 1x, so minus 1x, and 10 take away 16 is minus 6, and that now equals 0, and then we can solve it. So all I did was minus 2x squared, minus 12x, and minus 16 from both sides, so that equals 0. Now we can solve it. So looking at this now, I just need to factorise it. So the factors of 1 and 6 are either 1 and 6 or 2 and 3, and it's going to be 3 in the middle there, so it'd be x plus 2 and x minus 3. And that would give us minus 1 in the middle, and that's what equals 0. So we've got two solutions here, which is why it says find the possible values of x. We've got this solution here. You got x could equal minus 2, and you got the one to the right of that as well. You got x could equal 3. So there's your two solutions, x equals 2 and x equals 3. Finish that off. Last question here, we've got a speed time graph, very similar to a velocity time graph as well, similar process in what we do. So part A says find an estimate for the distance travelled in the first 10 seconds. We know that our formula, speed is distance over time. So actually working out distance is speed times time, which just means all we have to do is work out the area underneath the graph. So normally it would say to split this into equal widths. Okay, I haven't actually added it to this one, but we're going to split it into 5 equal widths. So along the bottom, along the time, it goes up to 10. So each bar I'm going to draw in, I'm going to split it at 2. So every 2 seconds, I'm going to split the shape up and draw it in. Here we go. And I'm going to connect those up together here to make the shape. So I've got a triangle there, a trapezium, another trapezium, another trapezium, and a final trapezium there. And this is going to be quite awkward for me to do on here, but I'm going to give it my best shot. So the height of this triangle, I'm going to write them all in because the base of all these shapes is 2. But I just need to work out the area of all these shapes. So the height of the triangle there, as best as I can see, looks like 27. So the height of that is 27. The height of the next trapezium, as best as I can, is 44. You just need to be super accurate with these. The height of the next one is 50. The height of this next one here is what looks like 44 again to me. And this final height at the end here is 20. So what I need to do is work out the area of them all. So I'm going to label these up 1, 2, 3, 4 and 5 and work out the area of all these shapes. So shape number 1's a triangle, so base times height, 2 times 27, and halve it is 27. So just having a look at the units here, it's metres per second, so the shape 1 is representing 27 metres. Shape 2, we've got the area of a trapezium here. Don't forget the area of a trapezium formula, which is add together the parallel sides, or a plus b, divide it by 2, and then times it by the height, which in this case is the distance between them. Now it's really nice when you've got a distance of 2 between them, because actually dividing by 2 and times by 2 cancel each other out. So actually you just have to add up those two parallel sides. So for number 2, 27 add 44 is going to give us 71 metres. Again, plug it into this formula if it doesn't have a width of 2. Number 3 is going to give us 94, 44 plus 50, so 94 metres. Number 4, 50 plus, number 4 is the same again, 94 metres again. And then number 5 is 44 plus 20, so 64 metres. So all we need to do is add them all up, which I'm going to do on the calculator. So adding all of those up, we've got 27 plus 71 plus 94 plus 94 plus 64. And that gives us a total distance there of 350 metres. Right, there we go, just adding them all up. Let's put that down the bottom there, 350. Okay, so one more thing that we could have a look at on here, and it's part B. It says work out an estimate for the acceleration at 2 seconds. Now this is a bit awkward to do on the same graph, but what I'm going to do is I'm just going to get rid of some of the drawings here around the 2 second mark. Now in order to get an estimation for the acceleration, we've got to draw a tangent at this point here, and that can be awkward. I've obviously just gone up from 2 there to find out where that is. So you just got to get your ruler really carefully and make sure that it just touches at that point and then skims off. Now it's very hard for me to do on the screen here, but that's it, drawing a tangent there. And then all you need to do is draw a little triangle underneath or above and work out the rise over the run, or the change in y over change in x. Okay, so if I just draw this in, and a little tip if it's a non-calculator is to try and get that change in x to be 1. So I'm just going to have a look to see if I can actually do that. So if I go from here, I go across 1, 2, 3, 4, 5 squares, that's a change in x of 1, and I get that distance there, which for me actually perfectly goes to 10. So it's going to be different on the paper because it's quite hard to do it on here, but that gives me a 1 and a 10. And obviously to work out the gradient, you do the change in y over the change in x, and mine comes out as change in y is 10 and the change in x is 1, and it's sloping upwards, so it is positive, and that gives me a gradient of 10. So in terms of an acceleration here, my acceleration would be 10 meters per second squared. And that's your units for acceleration there. So 10 meters per second squared is my acceleration. Right, and that's the end of ratio and proportion.